So the last thing to do before we know our robot schema is good or right is to test it. And I always do it with a cube test. I will show you how it's done. First we go to model and import our test block. Like this. Here it is, our test block. Then we go to machining tab, and before making any operations, oh, and I see the test block is not in the right place. So we go back to model, go to machining, then click this and go to spatial transformations. Then locate 0, X middle, Y middle, and Z minimum. Apply, and now it is exactly in the middle of my rotary table. By the way, I will also put this file in the description of the video. This is a file for a rotary table originally. I think you can also use it on a fixed table, or you can make something like this for your fixed table. Okay, we go back to machining. And now, again, before making any operations, make sure your tool orientation is on up, like that. And also your workpiece, you want 3 millimeters of stock, except on negative Z. Make sure same stock is turned off afterwards for if you click in 0. Otherwise, when you click 0, everything will become 0 again. So you have to make it 3, then turn off same stock, and then fill in 0. Add, and now we have a box around part. Now we can add our first operation. That will be roughing plane. Create. And first thing to do here is 6th axis control. We will put this on fixed vector and X minus. Then we go to setup. And oh, wait, I see I have the wrong mill. I will set my 16mm ball nose mill like that. Then we want to change this to 10, and we want to change this to 20. Perfect. This we want to set it to 20. Then for our parameters, I will have 3mm stock. And my approach has to be G53. Also for this one. And then everything is all right, and then run. And we have an error. I have to click my top TCP. I have 2 TCP points, but for you with a manual TCP calibration, you will have 1, and you don't have this option. I do. You can also if you want to. Okay, now it's good, and we can simulate it. Perfect. That's our first operation. Now we go to our second. That will be roughing plane 2. For this, we have to make a sketch first. So we are going back to model and make a sketch, new sketch. And we have to select a new plane, and we have to have X and Z. So we will select ZX. Okay. Perfect. Now zoom in. And we want to make a box with 2 points over here and over here, like that. It's perfect. Then we also want the ZY plane, or YZ. Okay. And again, a box with 2 points around here. Like that. Perfect. Now we can go back to machining, and we will select this line and add it as job zone. And then we also want our strategy on 10 millimeters. And we still want our 16 millimeter ball nose mill. So 10 and 20. Okay. So this has to be, fixed factor x minus, and we also want to mill from here, like this. Back to strategy, and then we want this almost like this. That's all right. Okay, still 3 millimeter stock. And we want this from previous again. Okay, and then run. Simulate. Okay, looks good to me. Now we want our third operation, again roughing plane. For this operation we will copy, we will actually delete this one. Yes, delete. We will copy this one, or duplicate, sorry. Then go to tool orientation and make this 180, like this. Calculate. Perfect. Now we want to duplicate it again, but now we want it to be 90 degrees, and we have to delete this one, and we will select this one. Is the right one? I guess so. Yeah, that's the right one. Okay, calculate and duplicate. And we have to set tool orientation to 240. No, not 240. 270, sorry. Okay, now we want to simulate those last two. Okay, perfect. Now we have our roughing planes done, and we will continue to our scallop operations. So we go to add operation, and now we select scallop over here. Select our 16 millimeter ball nose mill. We want this on the top. Fixed factor plus Y. And then go to strategy, bottom. Okay, looks good, except this one. It has to be on 220. And we have to set setup to orientation from up. Okay, like that, 220, perfect. Now we don't want to leave any stock anymore. This one from previous, return also from previous, and now everything looks good. Run. Perfect. Now for all the sides, we will add a scallop operation again. We go to setup, TSP from top, and here I want it from the left, I guess. Yeah, right now from the left. Okay. Sixth axis control is to be a fixed vector again, x minus. And now we will select our sketch again. This is our job zone. Go to strategy, and this has to be on 80 millimeters. Yep. Okay, and run. Perfect. And now duplicate. Turn it to 90, I guess. Am I right? Yes, 90. And now duplicate this again. Now delete this one and select this. And before you can select our other sketch line, you first have to turn it around to 180 in this case. And now we can select our job zone again. And we can click on calculate. And then duplicate the last one. And go to setup. And now turn it 90 degrees again. No, 180, so to 0 again. And now click calculate. And we have to simulate the last parts. And now everything is in the green here. That's perfect. And our test block is done. So what do we want to do with this now? We have to check with our eyes. Are these lines the same everywhere? Is there a circle everywhere? And is it milled out perfectly like it is over here? So now we have to test this in real life. So what we have to do is go to machining, and I see our last operations have 20 millimeter ball nose. Those have to be 16. Okay, just run them. So again, no errors. So now we go to post processor, and you have to select KUKA robot.sppx. That's the standard KUKA post-processor you can find in the ENCY folder. Just click Run. Yes, I want to create folder. And here it is, your whole ENCY code output. Now we have to set this on a USB stick and run it on the robot. So now the very last step to determine if everything is right is to place the block on your rotary table. I already did this. Make sure that the block is exactly in the middle, that everything is centered. Otherwise this test will not work. And make sure everything is running all right. So the last thing for me to do now is just to shut the doors, for the safety of course. And we will start the program. That's our milling motor. And now we just wait until the project is fully done and we can check our test block, and that's it. Okay, as you can see, our robot is done with the test. So we will check it now. Looks quite good in my opinion. For manual calibration, and what I mean by that, you also have robot integrators with beautiful measurement materials like lasers for the TCP and other calibration materials for the table, rotary table, or somewhere another axis. They can do it a lot better than me with my manual calibrations. So as you can see, this was not supposed to be here. Same for this, same for this. These are a few lines that are here now. When you do it better and more secure, these will not be there. But for the first project, it's good enough. So if you want to be more precise, contact your robot integrator or contact a robot integrator that knows how to work with ENCY. And that's it for this robot tutorial video. I will see you in next videos for sure with other projects. And for now, thank you for watching to these videos.